Hello students, welcome back for our chemistry class. Today we are still continuing with our topic of electrochemistry, still under redox reactions. But today our objective is to ensure that at the end of this session you should be able to apply the change in oxidation number to identify redox reaction. So should be able to use change in oxidation number to identify redox reactions. Now we are in the last definition of redox reactions, and here we are going to define oxidation as an increase in oxidation numbers, and then reduction as a decrease in oxidation numbers. Therefore, in redox reaction, we will say that redox is a simultaneous increase in oxidation numbers, and at the same time there is also a decrease in oxidation number, meaning simultaneous increase and decrease in oxidation numbers during a chemical reaction. So the number increases and decreases simultaneously during a chemical change. Then we come to the oxidizing agents. Oxidizing agent, therefore, is the substance whose oxidation number decreases, while the reducing agent is the substance whose oxidation number increases. But now we are going to go a step further and apply these definitions and ideas practically in given questions. So in our first example, we are told, using the concept stroke idea of oxidation numbers as increase and decrease in oxidation numbers, the oxidizing and reducing species or agent can be determined as in the following examples. So based on the change in oxidation numbers, and by use of the following reactions, show the following. One, you're supposed to show the oxidation process, reduction process, oxidizing agent, reducing agent. We are supposed to show all that. Our first equation, which is number one, let me make it clear here. So our first equation is where we are given copper plus nitric 5 acids, which is aqueous, copper is solid, to give copper 2 nitrates plus nitrogen 4 oxides plus water. This is what we have. So we are going to consider copper changing to copper 2 oxides. We want to identify oxidation process, reduction process, oxidizing agent, reducing agent. Then nitrogen is changing to that. So we have copper. The oxidation number of copper from our rules, free element is assigned 0. Copper 2 nitrate, copper 2. This one means it is the ion as a valence of 2. So copper here is positive 2. Alright, then nitrogen. We are in nitrogen, so we'll calculate oxidation number of nitrogen in nitric 5 acid. So hydrogen here is positive 1. Nitrogen we don't know, let's use Y. Oxygen is negative 2 times 3. we should get the overall charge. This thing has a 0 charge, so we equate it to 0. So we will have 1 plus y minus 6 is equal to 0. Then we will have y is equal to positive 6 minus y. Y is equal to 5. So here nitrogen is positive 5. That's why we call it nitric 5 acid, nitric 5 acid. Then we calculate for nitrogen in nitrogen form. So in nitrogen form, nitrogen is y because we don't know nitrogen. Oxygen is negative 2 times 2. You get 0. So you get 0. Therefore, y is equal to positive 4. Positive 4. That's why you call it nitrogen 4 oxide. Alright, so an increase from 0 to positive 2 is an increase. An increase in oxidation number is called oxidation process. So we have shown that copper is being oxidized to copper 2. Positive 5 to positive 4 is a decrease. A decrease in oxidation number is what? Reduction. Therefore, we can say that nitric 5 acid is reduced to nitrogen 4 oxide and water. Then, so we have shown oxidizing and reduction process. Now let's identify oxidizing agents. What is oxidizing agent? A substance whose oxidation number decreases. This one is the one which has decreased. So the oxidizing agent is nitric 5 acid. Why? Because the oxidation number of nitrogen in nitric 5 acids has decreased from positive 5 to positive 4. And you must quote these numbers. You don't just say it decreases. How? By what figure? So the oxidizing agent is nitric 5 acid. Why? Because the oxidation number of nitrogen in nitric 5 acid has decreased from positive 5 to positive 4. Then we are supposed to identify reducing agents. So reducing agent is the substance whose oxidation number increases 0 to positive 2. This is an increase. So it is copper. Why? Because the oxidation number of copper has increased from 0, that is from 0 to positive 2. From 0 to positive 2. So that is our first example. Let's look at the second example. Our second example is a reaction that is used in Form 2 to demonstrate chemical properties of sulfoxide. So we have carbon plus sulfuric acid to give carbon 4 oxide plus sulfur 4 oxide plus water. So this one is a liquid. So again, carbon is changing to carbon 4 oxide. Sulfuric 6 acid to sulfur 4 oxide. Carbon here is 0. Here we have carbon 4 oxide. So CO2. We don't know carbon, but oxygen is -2 times 2 will give us 0. So Y is equal to plus 4. Carbon 4 oxide. Sulfuric 6. Okay, we can calculate sulfur in sulfuric 6 acid. Hydrogen here is +1 times 2 plus sulfur to give -2 times 4. The overall charge is 0. So 2 plus y minus 8 is equal to 0. Y is equal to plus 8 minus 2. Y is plus 6. Y is equal to plus 6. So here sulfur is plus 6. Sulfuric 6 acid. That is why that 6 must be there in that name. Sulfur 4 is normally +4. Sulfur 4 oxide. So sulfur here is +4 if you calculate. So an increase is oxidation. A decrease in oxidation number is reduction. After that, we can now do what? Identify oxidizing agents. Oxidizing agents. So oxidizing agent is the one whose oxidation number decreases. +6 to +4 is a decrease. So our oxidizing agent is sulfuric 6 acid. Why? Because the oxidation number of sulfur in sulfuric 6 acid decreases from +6 to +4. +6 to +4. Then we have the reducing agents. Reducing agents. So for the reducing agents, we have carbon. Carbon is the reducing agent because its oxidation number increases from 0 to +4. 0 to +4. So that's how we identify oxidizing and reducing agents. Oxidizing and reducing agent. Our last example. Our last example is copper 2. Let me put it this way. Zinc plus copper 2 to give zinc plus copper. Zinc to zinc 2. Copper to copper 2. 0 to +2. +2 to 0. So this is 0 charge. +2. +2 zero charge. And increases oxidation. And decrease is reduction process. So zinc is being oxidized, undergoing oxidation. Copper 2 is being reduced. The oxidizing agent now is the one whose oxidation number decreases, which is copper 2. Reason its oxidation number decreases from positive 2 to 0. Reducing agents is what? Zinc metal. Why? Its oxidation number increases from 0 to positive 2. And so, make sure you attempt this: passing fluorine gas through potassium iodide, passing fluorine gas through potassium iodide, placing into magnesium and copper into a solution of like 2 nitrates. That is a typing error. But then reaction between acidified potassium dichromate 6 and iron 2 sulfates. And then reaction between acidified potassium manganate 7 and iron 2 sulfates. So that one brings us to the end of our class. I hope you have gained from our discussion. Thank you for watching.